Hi, everybody. I'm Ryan Berry. I am the maintainer for oVirt Node Next Generation, or oVirt Node 4.0, oVirt Node 4.1, coming out very soon. Welcome to a technical deep dive on RPM persistence inside oVirt Node 4.1. We're going to start off with a bit of background, going back and forth on what is different between oVirt Node Legacy, or essentially oVirt Node 3.6, oVirt Node 3.5, and oVirt Node 4.0 or 4.1. This is important essentially to go over because oVirt Node Legacy did not have any way to have a writable root file system. Every time you booted the image, you booted into essentially the same image which was deployed on the ISO. And so it was possible to mod the root file system read-write, and we had a mechanism for persisting files, as we called it, but these were mounted using the read-write tools on the fly, and there was no real way to keep them back and forth. So for a little bit of background, oVirt Node NG was designed to be similar to Vintage Node in a lot of ways. The images should be composable. And by that, we mean that you should not be enabling Yum repositories and installing a bunch of packages one by one. Instead, we wanted to ship an entire image that we could install through the installer. And when you upgrade, you would install an entirely new image rather than individual package updates. The other thing was that we wanted the system partitioning to be a lot more flexible. We wrote our own installer for Vintage oVirt Node, and so we had some fixed assumptions about what size the root file system should be and what size boot should be. But we also wanted the ability to be able to install multiple images inside LVM volume without having to do any manual messing with the partition table. In order to do this, we use LVM thin provisioning in order to do everything. We use a thin LVM pool when you install, and every image you install is on LVM thin volume. This gives us the flexibility to go through, and even if you have used, say, nominally 30 gigabytes of a 30 gigabyte volume group, it effectively operates similar to sparse files, and the only space that's used is the space which is actually used. This means that we can repeatedly ship 6 gigabyte images, and you can install them on a 60 gigabyte root volume, and you can install as many as you want. This adds a lot of ability for us to deploy without worrying about the installer code at all. One of the downsides of this is that the tooling for LVM itself is a little bit cumbersome. If you've never used LVM thin provisioning, it is a bit of a hassle to go through and manually add new volumes or manually remove new volumes. Additionally, we wanted to be able to essentially flag a particular volume as running oVirt Node. In order to do this, we wrote a utility which was originally designed to be a wrapper around LVM, but it has ended up also handling updates and everything else which handles LVM, essentially called image-based. Image-based is basically the core of oVirt Node Next Generation. It does almost everything which we would want to do. For all of the user-facing aspects, we use Cockpit, and we wrote some tooling around that called Node.ctl, which will provide information that you need. But for the system-level utilities, image-based handles all of our image deployments. So why do we want to support RPM persistence? One of the largest advantages of using next generation Node is that it has a writable root file system, and that writable root file system is the same every time you reboot. If you create a file in Etsy and you reboot, it'll be there. You don't have to do anything else. This makes it a lot easier for users and administrators to tie it into Ansible or Chef or Puppet or Salt or anything else you want to do. It also makes it easy for you to install, say, Vim or kernel modules or anything else you'd want to use without having to go through and write or modify a new ISO, which was the way that vintage oVirt Node had to be modified. In the original implementation of 4.0, we had a very trivial yum plugin which warned you essentially that any packages you installed would be gone as soon as you rebooted it, or as soon as you installed a new image, rather. We did this because we wanted to let you know that you were able to install packages. You could install Vim, you could install HTTPD, but when you installed a new image, the new image would deploy an entirely new root file system, and it would have no idea that those packages are there. This warning seemed reasonable at the time, but it obviously was not ideal to force users to redeploy Puppet manifests every time they updated it. Puppet is pretty good about this, and so is Ansible, but even so, we didn't really want to keep things that way in the long run. In order for us to persist RPMs, and here we're using the same verbiage which we used in vintage oVirt Node, but to persist in RPM across image upgrades means that everything you do sticks no matter what you do. And it makes for a consistent, easily managed system, which keeps all the advantages of us deploying image by image, meaning that we ship a known good set of packages, and we don't have to worry about this hypervisor and that hypervisor being a little bit different. But it also provides the flexibility that users and administrators want. We're getting a little bit closer to CentOS in the way that this is actually built. And so, like CentOS, we want you to be able to install anything or any tooling which you are interested in. Say, image-based in general handles all of the following. Tagging of volume groups, physical volumes, and logical volumes to identify what's used by Rev or oVirt. Creation of LVM snapshots for running images. Updating 2 new images. Sanity checking the running system, essentially to make sure that you are running onside thin logical volume instead of booting into a regular LV, since what you installed CentOS on will still be there. Verifying that the new images are compatible, and by this we basically mean that you're upgrading from CentOS to CentOS instead of CentOS to a Fedora image, for example. Managing the bootloader configuration, and this item sounds a little bit strange since it looks very similar to CentOS and most of the utilities that you already use in order to modify the bootloader on CentOS, like grub2makeconfig and grubby, will work in general. But we install all of our kernels and initrds inside subdirectories inside /boot. And so when we say that we're managing the bootloader configuration, we essentially mean that here we are making grub a little bit aware that there is a new kernel that we have deployed, since new kernel package, which runs as part of the kernel postscripts, won't actually run if we deploy a new image. It's run inside the new image, but it's not triggered directly by oVirt Node. And then in 4.1, we support persisting packages across updates. This is also done through image-based, since image-based handles essentially all the update mechanisms along with everything else. There are some events and some plugins which handle various pieces of the upgrade. For a little more background, deploying from the image means that the image itself has a couple of steps taken before we actually deploy it. etc machine ID is truncated, so systemd will go through and rewrite a new one when you install for the first time. We disable every Yum repository that we use to build. Here we whitelist a specific list of packages from the oVirt repositories, which mostly comes down to the appliance for hosted engine and updates to oVirt node itself. We wipe out all the networking files, which Anaconda likes to write by itself, but we don't want you to see any of those when you boot into the actual image. And down at the bottom, we see the more interesting things which are taken. First, we relocate the RPMDB. The file system layout assumes that when we go through, var will be a separate volume. And using var as a separate volume means that every time you boot into a new oVirt node image, we guarantee that var is the same. And this is because it's called stateless data, or things which may otherwise need to be persistent, like the Yum cache, they all write to var anyway. And so by keeping var the same, if you boot from one oVirt node image into another oVirt node image, everything in var will be the same as it already is. To make this work nicely, we create a symlink into varlib RPM, which points at user share RPM for the RPMDB on whatever image that you are running. And this means that when you boot back and forth between images, RPM is able to identify the packages which are actually there. But by itself, the packages are what's on the running image, not any kind of universal state inside the RPMDB. When we do all this, we keep the contents of var and etc, which were there when we built the image, in user share factory. We do this so there are some utilities or plugins for image-based. If you run image-based diff, you can see a difference between what you have done or what we have done versus what the image was actually built with. This makes it a little bit easier for us to go through and check to see what changed. It also makes it possible to do a three-way diff on the updates. And lastly, we write the NVR of the oVirt node release to user share image-based build meta NVR. This is a rather long path, but user share image-based has a few things inside of it. Using the NVR means that when you boot in, we can keep track of what NVR you're running without needing to parse etc OS release. Inside OS release, pretty name is the only field which we change, and pretty name will tell you what you're actually running. But using the NVR itself allows us to basically take it in one line, going across if you run, say, image-based version or image-based W, which will tell you what image you're running on. When we actually install, we told you a little bit about requiring a thinly provisioned LVM pool with var as a separate volume. But inside the PostScript, which is automatically handled for you if you use the ISO to install, if you write a kickstart, you'll have to write this yourself. Just the one line, which is image-based layout init. Image-based layout init pulls the NVR from that file. If it can't be found, probably because you installed image-based on a regular RHEL system, you can specify it yourself. But image-based layout init will check that NVR, and then it goes through and it tags a whole bunch of volumes. So if you run like LVM LVs -o name comma tags, you will see image-based tags. And this is how we keep track of what image-based is actually using and what oVirt Node is actually using. And this has the advantage that if you go through and run, say, your own logical volume for some reason in a kickstart, or if you specify it inside Anaconda, we won't touch that. We have an idea of what we created and what we're going to use. We make a read-only snapshot as the basis for new layers, just for a little bit of safety and to make diffing easier. And when we go through and add a new layer, we basically create a new LV that is the NVR +1. Anytime you run image-based W, you will see something like oVirt Node NG, the date, something 0 + 1. So like oVirt Node NG-406.1.2017, etc. +1. It's possible to add a new layer on top of this, and you will get, say, +2. We don't actually use this functionality, but it is there in case you are curious about it, or for some reason you want to create a new layer and play around with it. Image-based communicates by using events. We don't actually have a daemon here, but the image-based application itself communicates through events, which makes it easier for us to break things up. And this ties into the RPM persistence because we can just create a new event for it, which triggers every time we build a new layer. Every time you install image-based, it will go through and emit pre-argparse, and any plugins which want to respond to this and add their options to argparse can. So let's say image-based layout init emits a couple of events. We mentioned the events because a new layer added is triggered every time we add a new update. As part of the post init layout event, we take etc from the new image, we bind mounted across, we check the compatibility, we copy all of your files from etc and root to the new layer. We make sure that the UIDs and GIDs are the same. This is kind of a strange step, but it is necessary for like the Fedora Cloud Imager and for oVirt Node NG, because many in package which you install guarantee that you'll have a user ID, say, below 1024, but they don't guarantee what the user ID is going to be. And so if we are copying etc back and forth and the numeric user ID or group ID doesn't line up, things don't behave the way you want them to. And so going through and doing this ensures basically that when you boot the new image, all your permissions are correct. Similarly, we go through the entire RPM database and we verify that permissions and ownership are the same. Since RPM postscripts run as part of the actual image and not as part of the image update, any bug fixes which may have happened to land in an RPM postscript won't actually happen with the etc and the root that we copy across. We update the bootloader. We run drakit to generate a new init ID, and again in 4.1 we persist the RPMs. There is a little bit of a layout of what a running system will actually look like. And so you can see here that there's physical storage, and on top of that, boot is obviously not an LVM thin pool. We actually have an open bug about this because you can put boot on LVM, but it does not recognize thin pools. So eventually we will move this across. And on top of this, we can see two example layers. There's a read-only snapshot and a read-write snapshot on top of that with +1 appended. And these are actually what you boot into. In order to build oVirt Node NG, we pass a CentOS boot ISO into Live Media Creator along with a very, very small Kickstarter. We pretty much just install Anaconda tools and drakit config generic to make sure the image will run everywhere. We install the oVirt release RPM, and the copper for cockpit in order to make sure that we can pull in the oVirt packages from whichever release we're running and cockpit for management. And then we install oVirt release host node, which pulls in all the dependencies. I'm mentioning this here because if you've ever worked with vintage oVirt node, you know that we kept a very long list of packages which actually needed to be installed. And you had to update those yourself if you wanted to do anything to it. Now, everything is kept inside oVirt release host node itself. This is a sub package of oVirt release, but it makes the separation building a lot cleaner. And the expectation here for users is that if you have something which you want to install, like collectd or something similar, you can just put it inside there and you are okay to go. Any updates to any other packages like VDSM will be pulled in automatically. And then we generate a placeholder RPM. This is actually empty, and it's there only to be updated. Otherwise, RPM inside Anaconda, if we don't use a placeholder, gets a little bit confused, and it tries to install the image update immediately rather than the actual image. And this recurses, which isn't exactly what we want. Inside Jenkins, which is where we publish all of our ISOs from, we generate a very small product image to create a build stamp file. This is how we break Anaconda, brand Anaconda, sorry. And we generate an updates.image file. This is true until at least oVirt node ng 4.0.4. It's dropped after that. But this was to pull in a couple of fixes to Anaconda from CentOS 7.3. And then we shove it in with make ISOFS. With a little bit of background on how oVirt node ng actually works, the package persistence works by tying into the Yum API. I mentioned that we have a Yum plugin which actually works for this, but we are not using RPM directly. The RPM API for RPM plugins is a little bit limited, and it's hard to actually pull out the name of the packages. So we essentially go through and have a small Yum plugin, which will go through and find the RPM which you're installing if you like RPM UVH something, and we save it off inside var. The Yum API is very well documented, but it is essentially a PyDoc, and it's difficult to tell sometimes what you're going to get out of the conduit in different transaction hooks. There are something like 10 different transactions which you can hook into, or 10 different conduits which you can hook into, and not all of them provide what we want. Yum's main plugin conduit, and here we are using pretrans for our plugin. Let's just pull in the entire transaction set. And here we can see every package which we are going to install, every package which is going to be uninstalled, and every package which is going to be updated, either as a dependency or installed as a dependency or updated as a dependency. We can also pull out some other bits like obsoletes and a couple other things, and we use all of those. We want you to be able to like Yum install Vim, and Vim has like 3 dependencies, I think. So we will say Vim and all of the dependencies. It's actually an instance of transaction data inside Yum, and there's some more information inside that, but we're not using any of it. There are some links on the slides here which you can use to get across to see what the actual Yum API looks like if you're interested. All of these packages return Yum available package, which is Yum package object. And if you've ever used the Yum API, the Yum package object essentially mirrors the RPM API itself. A lot of the things which we would want to find, like NVR or NVRA, are there. But the most important thing for us is that the Yum package object also provides .local package, which shows us where it is. either in Yum's cache if you've pulled it down from a repository somewhere, or locally if you've used Yum local install. There is a DNF plugin for image-based, but since we are not shipping Fedora images, this has been tested and is not used for now. So I'm not going to go over the DNF API. It is nicer than the Yum API, I will say that, but it doesn't match up one-to-one. The links here are to the Yum and DNF plugins for image-based themselves. If you want to take a look, at some point, CentOS will start using DNF, and then we'll actually use the plugin for oVirt Node, but we are not for now. The plugins are essentially, since we know that var is the same, we'll grab the local package file, and they stash it off in var image-based persisted RPMs. If you persist a package and you go through and install HTTPD or some kernel mod, you will see the RPM file sitting in var image-based persisted RPMs. We picked var because we know it's always the same. This means that if you install oVirt Node 406, and sorry, this actually sounds, since the Yum plugin is only there for oVirt Node 4.1, let's say that you've installed oVirt Node 4.1.2, which is not out yet, but you've decided that you want to go back to 4.1.1 for some reason, maybe a blocker, but you've already installed packages. Keeping the packages inside var makes sure that even if you rolled back, any packages you installed in the newer layer are still there. So no matter which image you're running on, you will always get the same packages. In the same way, we hook into Yum pretrains in order to remove the packages. So if you Yum remove Vim, for example, we will remove it from var image-based persistent RPMs, so we don't try to install it again when you go through and update something else. So if you install something for troubleshooting, like SAR or something else which we don't automatically package, if you install it and you remove it, it will be gone. That is not going to stick around in every image you run forever. The image-based section of handling the RPMs is actually really, really small. It's something like 70 lines. When we say the system has been upgraded, we check whether it's a supported system. In this case, we mean that it uses RPMs, just in case image-based is used somewhere that uses like Debs. We don't currently package image-based for Debian systems, but the code itself is rather agnostic. LVM is LVM everywhere. And so if somebody somewhere decide to use Debian, we don't want to tell them that we can persist their packages because we cannot at the moment. If you happen to be using image-based on Debian or another system, please let us know, and we can see about adding persistence to that as well, or making a supported system. The events, when you say that the OS has been updated, essentially send a Python object that says what the new logical volume is and what the old logical volume is, along with paths to the actual devices. And we can go through and mount those. So we bind mount var into the new layer. The new layer is already mounted under temp generally, so we can bind mount var since we know image-based persisted RPMs is there. And we invoke NSEnter, although chroot would work just as well. And we really just do a blind RPM UVH of every package which we find there. We do this because, first of all, using Yum to install would call the persistence plugin again, since it is a Yum plugin. That would be okay, but it is unnecessary disk activity. Probably nothing bad would happen from using Yum by itself, but it adds a little bit of overhead, which we don't actually want. We could, or we thought about using a local Yum repository, which points at var image-based RPMs, or var image-based persisted RPMs, and using that local Yum repository when we install. But this was discarded for the same reasons as we're not using Yum. Basically, Recursive invocation of the plugin is probably not necessary here. And trying to install IPM packages one by one would fail to dep solve very, very fast. We don't want to figure out the dependency tree. And so if you RPM, IVH, VDSM, something, and we can't find the dependencies, we don't want to install it, force no deps or anything else. This would lead to the RPM dependency hell that everyone probably remembers from like Red Hat Linux 6 and 7 a long, long, long time ago. And so we are just installing everything all at once. Since everything has been installed via Yum through the Yum plugin, we can rely on the fact that dep solving will actually complete. There are a couple of limitations with using the Yum plugin implementation. First of all is that using RPM-I or RPM-U or any other invocation of RPM won't actually persist the files. The reason why we are not supporting RPM-I and RPM-U is that the RPM API is somewhat limited. Everything operates inside the context, essentially, of hooking some mechanism inside the RPM. You can hook the RPM postscript, you can hook the RPM prescript, you can hook any part of RPM that you want, but the RPM API does not provide a way to find the package file that the RPM is running from. And this is something that we wanted to do since we don't want to reconstruct the RPMs after the fact or on the fly, since the package would not be signed. And there's always a risk in trying to reverse engineer and completely re-implement RPM just for us. We thought that this was an acceptable risk since most configuration management systems like Ansible or Puppet are probably already using Yum repositories anyway. And the package classes for those configuration management systems do not call RPM directly in any case. They're going to Yum install something rather than RPM install. It is still something to keep in mind. If you RPM-UVH some package, you shouldn't expect it to be there after you upgrade to a new image. The second is that the persistence is only present on oVirt node 4.1 plus. We checked into reconstructing RPMs from the RPM DB, but we decided not to do this for the same reasons as we didn't write an RPM plugin. We could pull apart the RPM DB and reassemble most of the scripts through a combination of RPM-Q-scripts and RPM-QL. We could get most of what we wanted out to actually rebuild RPMs. But there's always the risk that some RPM is doing something very tricky, and we didn't want to be catching edge cases or trying to catch edge cases for this package or that package. And the package would obviously not be signed. We didn't have a way to pull the RPM signing key back out of the RPM DB, and so we did not do this. oVirt node 4.0 will still warn users that packages won't be persisted. That is correct. RPM persistence is supported on oVirt node NG 4.1, but if you install a package on 4.0.6, you should not expect it to be there when you update to oVirt node 4.1. This is an unfortunate technical limitation, but it's something that we did not find a particularly good way around. Going forward, upgrading from oVirt node 4.1.0 to 4.1.1, all your RPMs will be there. But if you want to use this feature, you should keep in mind that you need to start expecting it to work essentially with the oVirt 4.1.0 GA, or even now with the oVirt 4.1.0 RC. If you install one of the images from the RC, this will actually work. RPM persistence is unlikely to be backported. The actual code itself is really small and it's quite isolated. And it's possible that we could backport it, but after oVirt node 4.1 comes out, we expect most users to migrate. And so this is probably not something which we will do. So you can say the actual mechanisms for this are quite easy. So if we go to, I'm running a very small virtual machine. I need to clean out my SH keys. Every time I install a new VM, it comes up. So we are running on oVirt node ng 4.0.6. Ooh, and this is actually my mistake here. I set the demo machine running 4.0, so we'll have to update first. It said it's only supported on 4.1.0, which provides a slight limitation. I set up a test virtual machine, but it looks like I accidentally got rid of it. And this is not the correct one. So we can go through an update. And update to 4.1, and then proceed from there. I'm curious, I have not seen any questions inside the oVirt channel or the oVirt Slack, but it's possible that I missed them here. If anybody has any questions, I suppose the YouTube live chat works just as well as anything else. All right, I was just informed that YouTube screen sharing, let me figure out. Can we see the terminal now? The upgrade process here takes a little while. It's not actually stuck, but every time we run the update, we go through and take the new squash FS and we reboot and we rebuild Drake-it. Drake-it is invoked every single time, which means that the updates take a while sometimes. The actual activity here is Drake-it right in the background. Drake-it does not multi-thread particularly well, and so Drake-it here is probably taking up 100% of one of my CPUs and 0% of everything else. It'll probably take about another minute until I'm able to reboot, and then we can install an RPM and update to a new image. There we go. So we'll reboot the virtual machine, install an RPM, and that'll be upgrading again. So I'll install Vim here, since Vim is something which I use regularly, is the way to say it, I think. Years of muscle memory have made me type Vim instead of VI, and every time I type Vim and I find that it's not there, I'm disappointed. And so it is probably the first thing which I install on every system that I build, if it's not already there, as part of the kickstart. It's something that I will just add here, also because we know it has a very small dependency tree. And so it's easy to add from that perspective. So we can see here that Vim and all of its dependencies went into var image-based persisted RPMs. We also log everything down at the bottom. And so when we persist packages, we try to follow the normal Yum login mechanism of giving the date and what action we're taking, and then the name of the file which we're dealing with. So Vim is installed, and we can update again. I'm updating here to a non-existent version of oVirt node, but we are installed. I built it on the fly just so we can update to something and show the RPM persistence. It'll take a little bit to update here, but that is okay. I think we will come across and install everything. Take a sec. I'll grab this from local repo to make it a little bit faster. So we'll go with the update mechanism again here. We'll install everything. There won't actually be any output from Yum saying that's persistent the RPMs. We will see the normal output which we get. It is convenient from this sense that we can use Yum to update oVirt node ng versus vintage oVirt node, which had to be updated directly from the engine by putting a host into maintenance mode and then right-clicking and deploying an RPM, which essentially contained the ISO from the image itself. Being able to use Yum check update assuming that oVirt engine did not let you know that there was an update available. Being able to use yum check update, or for development, being able to just immediately yum update from the system makes the package installation flow somewhat cleaner. It is easier to tie into Contello or Foreman or your own yum repository or anything else you need without an additional step for manual intervention. By default, create a new window here. We create a very small whitelist, which lets us know which packages we can install. This pulls them in from the oVirt node repositories. So if we look at like oVirt 4.1 pre, we'll see include packages, which pulls in only these. But in the same way, every time there's an update published on the oVirt repositories, oVirt engine or yum update will pick it up directly. And it's very easy to install and update. You'll get a nice icon in the engine, which shows that you can do an actual update without installing anything else. And here we can check, but I'm sure the top process, here we might be in the middle of disk utility. I'm kind of just going to watch for Drake to pop up and show us what it's actually doing so I can get an idea of when it's going to be done. We wish sometimes that Yum had more verbose output. It's possible to add a lot of output to Yum, but we somewhat tried to avoid it. Adding a lot of debugging output to Yum doesn't mirror the normal Yum output, which we would see from any other packages or anything else we would do. I mean, other than warnings about a file existing and RPM making a new copy and RPM new, you as a user or administrator would not expect to Yum update something and see the screen flooded with debugging output. In the same sense, there is some available, like if we look at temp, we actually do keep a log. And some of the logs here are a list of open files, which we can get to actually go through and look at what's happening. In order to persist the RPMs, and make this typing here. And secondly, we can see what's going through to actually install the image. So kind of just waiting for the image install to finish so we can see the new LVs. I'm a little worried that we're going to run out of time for the live demo here, since I had accidentally deleted my test environment and I had to set up a new one while we were doing this. Does anybody have any questions? Like over on OFTC or the YouTube live chat would work, but I don't see any at the moment. So you just told me there are 2 questions in live chat. I don't see them on my screen. See if I can find out what they are. So the questions are whether or not CentOS and Fedora have cockpits. They do, actually. Fedora uses cockpit quite heavily. The Fedora server images and cloud images use cockpit as a primary administration mechanism. CentOS also ships it inside CentOS Extras, I think. Otherwise, if you want to use cockpit on CentOS, you are probably better off using the CentOS Copper, which is what we use inside oVirt Node, since the CentOS Copper aligns more closely with what they actually ship inside Cockpit in Fedora. The packaging is somewhat different between CentOS and Fedora, and using the Copper, make sure that you have all the latest and greatest if that is something you're interested in. The second question is whether or not we'll be able to use yum install to install Vim and Red Hat virtualization. And the answer to that is yes, you can, and no, you can't. If you create your own yum repository, or if you download the packages and yum locally install them, then it will work. I think the expectation is that users who are using Ansible or Chef or something like that probably have a local yum mirror anyway. It is unlikely that they are downloading everything from channels or RHN on every single system that they have set up. They're probably using something like Satellite or either a smaller yum repository, and this will work. However, we are not shipping, or we are not planning on shipping the entirety of the RHEL channels with the Red Hat virtualization host. And so you probably can't expect to yum install Vim unless you give yourself another repository which contains it. And fortunately, it looks like we're out of time while I still wait for the other update to come. But I would encourage you to try this out yourself and see if it works. If there are any questions, like I said, oVirt on OFTC works. We also have a Slack channel, at least for the time being. It's not very used, and so it may disappear. That is linked inside the description of the video. And I am rberry@redhat.com. Although I would suggest emailing users at oVirt.org and CCing me rather than just emailing me directly. Thanks for attending, everyone.